Thank you. So, I'm Stevens from Qoro Quantum, and our mission is to, as we were saying, scale quantum technologies. And this includes using all kinds of technologies together to ensure that quantum has the advantage it needs. So quantum computer, as we saw, it brings a new era of computing, and that's because it works fundamentally differently than classical computers. It has the ability to do superposition, it has entanglement, it has all these abilities, and with this comes a new revolution in computing. The applications of quantum computing are in pharma, so we can simulate molecules for drug discovery, in finance, which I'll touch on more, but we can simulate the stock market, portfolio optimization, and simulating nature so we can understand physics better. In finance, in particular, there are applications in portfolio optimization. We can scale the models to sizes that we can't possibly do with classical computers. In recession prediction, we can look at pattern recognition. We have nonlinearity, which allows the model to explore more possibilities. And in risk analysis, there's Monte Carlo simulation, which has an advantage when you use quantum computing. So my question is, and a lot of people are asking this, are why aren't we using quantum computers today to solve these problems? And the reason is, building practical scale quantum computers is challenging. When we have a quantum computer that is useful, it needs to have millions of qubits, the bits that we can encode information and process information with. But millions of qubits don't fit on a single quantum computer. And so we need to break this barrier in order for quantum computing to become practical. And this is our mission at Qoro Quantum. So we look at scaling quantum computing technology using the networks that we have available today. And what I mean by that is we have network protocols, we have high-performance computing centers, we have distributed computing, and we can leverage all of these aspects to perform distributed quantum computing today and tomorrow. So we're a software company. We don't build quantum computers, but we build the network stack to enable distributed quantum computing. We start at the application layer because quantum applications have specific forms. And with these forms, we can break the problems down into multiple programs, sub-programs. When we break them down into sub-programs, they need to be orchestrated across this network of computing devices. And we do this with a network orchestrator. And then we have to interface with multiple devices from multiple vendors that offer quantum computing technology and high-performance computing technology. And this seamless integration is very challenging. This is another part that we solve. So our stack, again, it takes the applications. It could be in any application. We're application agnostic, so to say. So we can handle portfolio optimization. We can handle these recession problems. And we take the problem, we break them down into subproblems so that they fit on the technology that is available today. Once we break them down, we orchestrate the execution across QPUs, or quantum processors, CPUs, and GPUs, which is exactly the environment that is being deployed in high-performance computing centers today. The advantages we bring are in orchestration. Everything is automated. The user doesn't have to think about where the program is going and how it runs. The runtime, everything is massively parallelized, so it runs on the device that it needs to get the biggest advantage. And it's distributed, meaning we can add security, we can also add resilience, and we can add obfuscation. The value we bring are to the end users who want to use quantum computers. They no longer have to think about what quantum technology is the best suited for their program, how do I break it down so it fits on the program, how do I do all these processing tasks. On the hardware side, the companies that build quantum computers, they don't have to think about building a network stack. And in high-performance computing, we bring the seamless integration that allows quantum computers to work side by side with classical. Why are we doing this today? It's because the next generation of computing is in quantum and high-performance computing sitting side by side. And we're seeing this from IBM, from IQM, IonQ, all over the world. High-performance computing centers are acquiring quantum computers for this purpose. Why is it us who's going to solve it? It's because we come from a long history of networking background. I come from a research in quantum networks and quantum computing. My co-founder and I, we met working at Cisco together. My co-founder, Dan, he has a long history of selling network technologies. So far, we've been part of multiple incubation programs, and we're part of this IBM consortium that is working to build these exact solutions for high-performance computing and quantum computing. What's next for us is we're currently raising a seed round. We're looking for 3.5 million euros so that we can expand. We have an MVP ready to go. We're looking for pilot projects. So if anyone is interested in using quantum computing today and can't get their programs to fit, you send them to us, and we'll make it work. So with that, I thank you for the time. Thanks for listening, and feel free to email me for any questions.
Thank you so much, Steven. Very interesting to see. I'd love to know what your go-to-market strategy is. Do you partner with hardware providers? Do you partner with HPCs or the like?
Yeah, so when we talk with high-performance computing centers, the common theme we see is they have the quantum computer, but they don't have any software to use it. And so that's our go-to-market. Firstly is connect the high-performance computing with the quantum computing and let the quantum programs run on that quantum computer. So we provide actually the software layer for that, the schedulers and the orchestrators. They provide the hardware and the interface, and we connect the dots like that.
Thank you. And what's your, if you think about the kind of midterm future, where do you see your company in 5 years?
Yeah, so our vision doesn't stop at just distributed quantum computing using classical networks. We're looking at distributed quantum computing where the quantum computers are connected with quantum channels. So now they can send qubits between each other, and as we heard, you need photonics for this, and the technology to enable this is just getting started. So there have been a few demonstrations of this, but commercialization is probably 5 years away.
Excellent. Thank you so much. That concludes